Hi students, in the previous video we have seen projection of points. By connecting two points we get a line. So in this video we are going to see projection of lines in very simple positions, only three positions. Now, for convenience and for better understanding, you preferably sit on a chair with a table in front of you. Keep the table touching a wall. What are we making? We are making an HP and VP. The table surface is HP and the wall is VP. Agreed? You are sitting in first quadrant. You are facing first quadrant. The other side of the room, provided a similar table is kept there, the table surface and the other side of the wall produce the second quadrant. Third quadrant is below the table in the other room. And the fourth quadrant is below your table, where you are sitting, below your table. That part of the table and the wall constitute fourth quadrant. So you are facing fourth quadrant. This is for convenience. This is a line in space. Hold your line in numerous positions in first quadrant. Agreed? For better understanding. Now we take this wall as VP and this floor as HP for reference. I am holding the line. You can preferably take a line of about 25 to 30 centimeters long. Hold the line parallel to HP and VP. When you say line is parallel to HP, what does it mean? All points on the line are equidistant from HP. When you say the line is parallel to VP, what does it mean? All points on the line are equidistant from VP. So I am holding the line parallel to both HP and VP. I hope you understand. Holding the line parallel to both HP and VP. What is the elevation? Tell me, what is the elevation? The elevation, when you project there two parallel lines, parallel rays to passing through both ends, you get a line of true length. What does true length means? True length means same length. What's the plan? Plan also will be a line. Plan also will be a line of true length and parallel to each other. You can see both plan and elevation are two lines of true length parallel to XY. You can physically verify that. This line is parallel to both HP and VP. You agree with me? Okay. Next I am holding the line parallel to VP and inclined to HP by an angle. What's the elevation? Since the line is parallel to VP, elevation is true length. A dash, B dash, true length, theta. The inclination to HP is theta. Theta is the letter always used to represent the inclination of a line to HP. Theta എന്നുള്ള letter കൊണ്ട് HP ആയിട്ടുള്ള inclination ആയിരിക്കും എപ്പോഴും കാണിക്കുന്നത്. So elevation is a line of true length inclined at theta to XY. What's the plan? Plan is a line. Short line length. Why short line length? L theta, L cos theta. Short line length and parallel to XY. How is this line? This line is parallel to VP inclined to HP by theta. Third case, I am holding this line parallel to HP and inclined to VP by an angle phi. What's the plan? Plan will be true length. When you project the plan will get true length. AB, true length, phi. What's elevation? Elevation will be short line length. Elevation will be short line length and parallel to XY. What is this line? Line is parallel to HP inclined to VP by phi. XY line, X, Y. These three are three simple positions of a line which you have to see and verify so many times. Then only it will come to your mind when it is required. You cannot solve any problem in lines without recalling this concept to your mind while doing it. You cannot solve any question. I don't mean that if you know this, you can solve any question. No. ഇതറിഞ്ഞാൽ ഏത് ക്വസ്റ്റ്യൻ ചെയ്യാൻ പറ്റുന്നല്ല, ഏത് ക്വസ്റ്റ്യൻ ചെയ്യണമെങ്കിലും ഈ സാധനം മനസ്സിൽ കൂടെ വരണം. കറക്റ്റ് സമയത്ത് ആവശ്യമുള്ള സാധനം വരണം. The correct thing has to come to your mind at the exact most appropriate time. For that, you have to be very, very thorough about that. That's why I asked to make the first quadrant in front of you, hold a pen, see it, talk. Ask yourself, how is the line? The line is parallel to VP and inclined to HP. What is the plan? Plan is a line of shortened line. What is elevation? Elevation is true line. Like that, you have to say and say and say so many times to become very thorough. Agreed? If you become very thorough about that, you will find projection of lines very comfortable. Because, as I said, this is used everywhere. There are so many other things to be used, but without this, you cannot proceed. Agreed? You can generalize like this. When a line is parallel to a plane and inclined to the other plane, when a line is parallel to a plane and inclined to the other plane, the projection onto the plane to which it is parallel will be true length, and the inclination to the other plane will be visible there. The projection onto the plane to which it is parallel is true length, and the inclination to the other plane will be visible there. Projection to the other plane will be shorter in length than parallel to itself. Projection to the other plane will be shorter in length than parallel to itself. That's all. You listen to it so many times, verify it, discuss among yourself, you become very thorough about this. That's all for today. In the next class, we will see a little bit complicated thing, line inclined to both planes. When the line is inclined to both planes, you cannot directly draw. We will see that in the next class once you become very thorough about this. Okay, bye.